I'm Rémy Braive and I'm working at CNRS and Université Paris 7 in Paris. I'm currently working with photonic crystal membranes. So in order to measure the displacement of this membrane, I'm using this design inside the membrane to be able to be more sensitive to the displacement of this structure. And so we are currently having two different perspectives and two objectives. One is to use a nonlinear resonator to study the dynamic of this oscillator, so to record in time the evolution of the displacement. And another one, which is more toward applications point of view, where we are trying to do oscillators. So in another word, to be closer to clocks, to measure, to be really precise reference in time with a mechanical oscillator, already working at in the gigahertz range. A mechanical oscillator is just any kind of element which is moving around a rest position, and it's moving back and forth, and like this oscillation around this position makes an oscillator. Quickly, we are using optics to measure the displacement of these oscillators. So we are using lasers, which are really sharp in wavelengths, in order to be able to be really sensitive to these oscillations. So we are using these lasers, and either in free space, so the laser is able to, we see the laser outside of in real, and we also using a vacuum chamber in order to avoid this mechanical oscillator to reduce the displacement due to the environment. So like this, we can control the environment of this oscillator. So this is the two techniques that we basically are using at CNRS to measure this mechanical resonance and these mechanical oscillators. What we are looking for is a really small displacement. So we need to get rid of any kind of perturbation around this tiny object. So like this, we are more sensitive to the displacement and to what we are looking for. So if we are in a non-controlled environment, there is so many other perturbations that we can disturb and cancel all the measurements that we want to do. Well, first, it's about skills that you have about either experiment or theory. And anyway, from my point of view, what brings me to more experimental physics, it's, let's say that I can touch things, what I'm doing, I can build something see it on a tabletop, and this is what was important for me when I started physics. My skills are more about experimental physics, and in any way, when you're doing experiments, you need to confront theory. So collaborating, or I'm working. I want to start collaboration with a theoretician in order to confront the experiment I do in my lab with a real theory, in order to understand in more details what I'm doing and in which direction I can go. And about artists. I started a new collaboration with an artist in the frame of a Vertigo project inside the HOT, and it's really interesting because you see a different approach of the physics, a different way of seeing the problem and that you may encounter in this kind of project. So it's really we are starting, but it's I really want to see how it goes and how we can collaborate together. I don't think it will change how I do research, but it brings you to think a little bit differently about how to present your research to someone who is completely outside of this field, and also to discuss really technical point for the presentation of this research. So it's really interesting to because there is completely different problematic in arts or in this kind of artistic meetings. So it's also interesting to meet this problem and to try to solve them. It's always, I mean, the main problem or the main difficulty is to stop using technical words and try to explain these technical words with other words, but which still you keep the meaning of what you are doing. And this is quite difficult because usually you in a daily routine you are working with colleagues that also are physicists, and so you used to use these words, and for me the main difficulty is to really explain in another word exactly what you are doing, and this is the main challenge for me. Besides the art, it's also to explain in a different word. It's also an exercise for me. I'm really looking for pursuing two different approaches. One which is more about really fundamental physics, and another one which will bring this optomechanics or the resonator oscillator closer to applications. And so we are also working on some part of the project in art is also to go toward applications, and so we are working on this actually.